12 and welcome to Purple Mountain Maths. We are doing the 2025 HSC paper for Mathematics Advanced. This is part 4. We'll do question 16 and 17 worth 12 marks. Question 16. Consider the function f of x equals x squared over e to the x. Part A. Find the stationary points of the function and determine their nature. Pause here to try yourself. Okay, first of all, we're going to recognise the structure of this function and the fact that we're going to need to use the quotient rule. Y dash equals v to u dx minus u to v dx all over v squared. In this case, u equals x squared and v equals e to the x. So u dash is 2x and v dash is e to the x. So substituting that in, e to the x all squared, e to the x times 2x minus x squared e to the x. I'm going to factorise on e to the x. In order just to cancel the e to the x. And then I can factorise again on the x. So y dash equals x 2 minus x all over e to the x. Now I'm interested in the stationary point, so that's the place where y dash equals 0. Y dash equals 0 if x equals 0 or if x equals 2. Let's find those 2 points. When x equals 0, I can see that y equals 0 because I'm substituting into the original function, x squared on e to the x. When x equals 2, I can see that y equals 4 over e squared. Okay, so we're going to find the second derivative to test the nature of the stationary points. So we know what y dash is here. We're going to need to set up another quotient rule. In this case, u equals 2x minus x squared. U dash equals 2 minus 2x. V equals e to the x, which means that v dash is also e to the x. So y double dash equals v squared on the bottom, which is e to the x squared, v times du dx minus u times dv dx. Factorise on e to the x. It would be e to the x outside of 2 minus 2x minus 2x plus x squared all over e to the x times e to the x. They'll cancel and we'll get 2 minus 4x plus x squared all over e to the x. Let's consider what that looks like at our two stationary points. At x equals 0, y double dash equals 2 minus 4 lots of 0 plus 0 squared on e to the 0, and that equals 2. This is positive, therefore we know that that is concave up. We have ourselves a minimum. At x equals the other stationary point, which is 2, y double dash equals 2 minus 8 plus 4 all over e squared, and that is minus 2 on e squared, and that is negative. So that's how we know we're concave down and we have a local maximum. Therefore, 0, 0 is a local min, and 2, 4 on e squared is a local max. Okay, question 16 continued. Says that a partially completed graph of f of x equals x squared on e to the x is shown. Use your answer from part A to complete the graph. Well, we know from before that 0, 0 is a local min, And we also know that 2, 4 on E squared is a local max. It's worthwhile knowing the value of 4 on E squared. In the calculator, you can work out that it's approximately 0.54. So we can now create that. I'm going to have a local min at the origin like that. And I'm going to connect that. And 2 just above this 0.54 is going to be a local max. And then I'm just going to make that curve as smooth as I can. And that's done. Okay, this is question 17. A borrower obtains a reducing balance loan of $800,000 to buy a house. Interest is charged at 0.5% monthly, compounded monthly. On the last day of each month, interest is added to the balance owing on the loan, and then the monthly repayment of $5,740 is made. Let AN be the balance owing on the loan at the end of N months. Show that A2 equals 800,000 times 1.005 squared minus 5740 times 1.005 minus 5740. Pause here to try it yourself. Okay, so we know that initially the reducing balance loan is 800,000. So A0 equals 800,000. I also note how often is it compounding, and the answer is monthly. I'm looking for that adverb. The interest is also provided to us monthly, so that's nice. We don't need to adjust that in any way. So A1 is going to be that amount of $800,000 multiplied by 1.005 and then less the payment of 5740. Similarly, setting it up in a recursive way, A2 will be the value that it was at A1 multiplied 1.005, subtract the payment of 5740. But we have an expression for A1, so let's put that in there. So A2 is this expression for A1, and all of that is A1, and then that is multiplied with 1.005, subtract 5740. Now I can expand that out, so I've actually got 800,000 times 1.005 squared minus 5740 times 1.005 minus 5740. And that's what they wanted us to show, so we say as required. Part B says show that AN equals 1148,000 minus 348,000 times 1.005 to the N. All right, so we already know from part A, we've got that constant, subtract 348,000 outside of 1.005 to the N, and that was what we were required to show as required. Okay, part C. After how many months will the balance owing on the loan first be less than 400,000? So in other words, they're inviting us to find N so that A of N is less than 400,000. Okay, so we have an expression for A of N, so let's use that. 1148,000 less 348,000, 1.005 to the N needs to be less than 400,000. Right, so we can just deal with that constant. Minus 348,000, 1.005 to the N has got to be less than 400 minus 1148 is negative 748,000. I can divide both sides by negative 348 and in so doing flip the direction. 748,000 over 348,000. So that's going to simplify to 187 on 87. And now I can take the natural log of both sides. The natural log of 1.005 to the N has to be bigger than the natural log of 187 on 87. I can pull down that n. N times the natural log of 1.005 is bigger than the natural log of 187 on 87. Divide both sides by the natural log of 1.005. So n has to be bigger than ln of 187 on 87 all over ln of 1.005. Just take care when you're dividing both sides by a constant, satisfy yourself that it's positive. So just check that ln of 1.005 is positive. And of course it is, because we know that ln of something greater than 1 is going to be positive, but it's always good to check. All right, so when I calculate that, my calculator knows the value of that. So let me find out what that is. Ln of 187 over 87 all over ln of 1.005. I get 153.422, but I need n to be a whole number. So my answer is n of 154 months. That's the end of part 4. Thanks for listening to Purple Mountain Maths.